The polar ice caps, located at the extreme northern and southern ends of our planet, are vast expanses of ice and snow that have shaped Earth's climate, ocean currents, and ecosystems for millions of years. These icy regions, found in the Arctic in the north and Antarctica in the south, may seem distant and isolated, but they play a critical role in the health and stability of the entire planet. Although they often feel far removed from our daily lives, the polar ice caps are, in fact, intimately connected to the world we know. Their importance extends beyond the frozen landscapes they occupy, influencing weather patterns, sea levels, and even the survival of species across the globe. Imagine standing at the edge of the Arctic Ocean, gazing out at a frozen expanse that stretches as far as the eye can see. The surface of the sea is covered by a thick layer of ice, broken only by cracks and small leads of open water where seals and whales might surface to breathe. In the distance, massive icebergs drift slowly through the water, their towering white forms a stark reminder of the cold, remote beauty of this region. The polar ice caps are places of extremes, extreme cold, extreme isolation, and extreme importance. The Arctic, which covers the region around the North Pole, is mostly composed of sea ice. This ice floats on the Arctic Ocean and is surrounded by the northernmost parts of continents like North America, Europe, and Asia. Unlike Antarctica, the Arctic does not have a landmass beneath its ice. Instead, the ice in the Arctic is dynamic and constantly shifting, growing during the winter months when the temperatures plummet and shrinking during the summer when the sun shines almost continuously. Arctic sea ice reaches its maximum extent in March and its minimum in September, creating a natural rhythm that has persisted for millennia. On the other side of the planet, Antarctica is a very different place. It is a vast, ice-covered continent, the fifth largest on Earth, and the coldest, driest, and windiest place on the planet. The Antarctic ice sheet covers roughly 14 million square kilometers and contains about 60% of the world's freshwater. Unlike the Arctic, where the ice floats on the ocean, Antarctic ice sits atop a massive landmass. The ice here can be several kilometers thick, and some of it has been in place for millions of years. The Antarctic ice sheet is divided into two parts, the East Antarctic ice sheet, which is larger and more stable, and the West Antarctic ice sheet, which is smaller and more vulnerable to melting. Together, the Arctic and Antarctic polar regions hold a vast majority of the Earth's ice, and this ice plays a crucial role in regulating the planet's climate. One of the most important functions of the polar ice caps is their ability to reflect sunlight. Ice and snow have a high albedo, meaning they reflect a large portion of the sunlight that hits them back into space. This helps keep the polar regions cold and prevents the Earth from absorbing too much heat. In this way, the polar ice caps act like a natural thermostat, helping to stabilize the planet's temperature. Without them, the Earth would absorb more heat, leading to higher global temperatures. But the polar ice caps are more than just passive reflectors of sunlight. They are active participants in the planet's climate system, influencing weather patterns and ocean currents around the globe. One of the ways they do this is by driving the process of thermohaline circulation, often referred to as the global conveyor belt of the oceans. This system of currents moves warm and cold water around the planet, regulating temperatures and distributing heat from the equator to the poles. In the polar regions, cold, salty water sinks to the bottom of the ocean, driving the deep currents that flow across the globe. As the polar ice caps melt, however, they release fresh water into the oceans, disrupting this process and potentially leading to changes in ocean circulation patterns. The polar ice caps also play a critical role in regulating sea levels. The ice sheets in Antarctica and Greenland, as well as the sea ice in the Arctic, contain enormous amounts of frozen water. When this ice melts, it can contribute to rising sea levels, which has the potential to inundate coastal areas around the world. While sea ice in the Arctic does not directly raise sea levels when it melts since it is already floating, melting ice on land, such as in Greenland and Antarctica, does. As global temperatures continue to rise due to climate change, the melting of polar ice has become one of the most pressing concerns for scientists and policymakers alike. The effects of melting ice are already being felt in many parts of the world. Over the past few decades, the Arctic has been warming at a rate more than twice as fast as the global average, a phenomenon known as Arctic amplification. As a result, the extent of Arctic sea ice has been shrinking, with record lows observed in recent years. The loss of sea ice has wide-reaching implications, not only for the Arctic ecosystem but also for global weather patterns. As the Arctic warms, it disrupts the jet stream, a fast-moving river of air that influences weather in the northern hemisphere. This disruption can lead to more extreme weather events, such as heat waves, cold snaps, and changes in precipitation patterns. In Antarctica, the situation is equally concerning. While parts of East Antarctica have remained relatively stable, West Antarctica has experienced significant ice loss in recent decades. The Thwaites Glacier, sometimes referred to as the Doomsday Glacier, is one of the most vulnerable parts of the West Antarctic ice sheet. If it were to collapse, it could trigger the loss of a significant portion of the ice sheet, leading to a rapid rise in sea levels. Scientists are closely monitoring the situation, as even a small increase in sea levels could have devastating consequences for low-lying coastal regions around the world. The melting of the polar ice caps is not just a future threat, it is happening right now. The Arctic sea ice minimum, which occurs each September, has been shrinking at an alarming rate, with some scientists predicting that the Arctic could be ice-free in the summer within a matter of decades. In Antarctica, the loss of ice from glaciers and ice shelves is contributing to rising sea levels at a faster rate than previously expected. The impacts of these changes are already being felt in many parts of the world, from the small island nations of the Pacific, where rising sea levels threaten to submerge entire communities, to the cities and towns along coastlines that are increasingly vulnerable to flooding and storm surges. The polar ice caps are also home to unique ecosystems that have adapted to the harsh conditions of the Arctic and Antarctic. In the Arctic, polar bears roam the sea ice, hunting seals and relying on the frozen landscape for survival. These majestic animals are perfectly adapted to their environment, with thick fur and a layer of blubber that insulates them from the cold. But as the sea ice melts, polar bears are finding it harder to hunt and are forced to travel greater distances in search of food. This has led to a decline in polar bear populations, and scientists warn that if the ice continues to disappear, these iconic animals could face extinction. The Arctic is also home to other species that depend on the ice, such as seals, walruses, and Arctic foxes. Many of these animals have developed specialized behaviors and adaptations to survive in the extreme cold. For example, walruses use the sea ice as a platform for resting and nursing their young, while seals rely on the ice to give birth and escape from predators. The loss of sea ice is disrupting these behaviors, threatening the survival of entire species and altering the delicate balance of the Arctic ecosystem. In Antarctica, the icy waters are home to a diverse range of marine life, including penguins, seals, and whales. The Southern Ocean, which surrounds Antarctica, is one of the most productive ecosystems on Earth, teeming with krill, fish, and other organisms that form the base of the food web. Penguins, in particular, are a symbol of Antarctic life, with species like the emperor penguin depending on the sea ice for breeding and raising their chicks. As the ice melts, penguin colonies are being forced to relocate, and some populations are declining as their food sources become scarcer. Despite the challenges facing the polar ice caps, there is hope. Scientists and conservationists around the world are working to better understand the processes driving ice loss and to develop strategies for mitigating the impacts of climate change. Efforts to reduce greenhouse gas emissions, protect vulnerable ecosystems, and raise awareness about the importance of the polar regions are all part of the broader goal of preserving these vital areas for future generations. One of the most important tools in the fight to protect the polar ice caps is scientific research. In recent years, advances in technology have allowed scientists to study the polar regions in greater detail than ever before. satellites provide real-time data on ice extent, thickness, and movement, while field researchers gather information on everything from ice core samples to the behavior of wildlife. This research is helping scientists build more accurate models of how the ice caps are responding to climate change and what the future may hold. Another key aspect of protecting the polar ice caps is international cooperation. The Arctic and Antarctic are governed by different sets of agreements, but both regions benefit from global efforts to limit environmental damage. The Antarctic Treaty, signed in 1959, is a landmark agreement that preserves Antarctica for peaceful purposes and scientific research. It prohibits military activity, mineral mining, and nuclear testing, ensuring that the continent remains a place of international collaboration and conservation. In the Arctic, countries like Canada, Russia, and the United States are working together to address issues such as shipping, resource extraction, and indigenous rights in a region that is becoming more accessible as the ice melts. Public awareness and education also play a crucial role in the efforts to protect the polar ice caps. Many people around the world are unaware of the rapid changes taking place in the polar regions and the consequences for the global climate. By raising awareness about the importance of the polar ice caps and the threats they face, individuals and organizations can inspire action and encourage governments to take meaningful steps to reduce emissions and protect the environment. The polar ice caps are more than just frozen landscapes at the ends of the Earth. They are integral to the health of the planet, influencing everything from weather patterns to sea levels to the survival of countless species. As the world warms, the future of the polar ice caps is uncertain, but one thing is clear: their fate is intertwined with our own. The decisions we make in the coming years will determine whether these vital regions continue to thrive or whether they disappear, taking with them the ecosystems and species that depend on them. In the end, the polar ice caps matter because they are a reminder of the interconnectedness of all life on Earth and the need for collective action to protect our planet for future generations.